Hello class, my name is Alexis Lojadal and the project topic is Rigor Mortis, and that's what I'll be discussing today. So, Rigor Mortis translates to the stiffness of death, which occurs after death because of a chemical reaction in the body. It starts when the muscle cells in the body can no longer produce ATP, which is the energy source required for muscle relaxation. Without ATP, the muscle fibers contract and cannot relax, leading to the stiffening of the muscles. This stiffness usually happens within 2 to 4 hours after death and affects all the muscles in the body at the same time. So, before rigor mortis sets in, the muscles are in a relaxed state known as primary flaccidity. This is a period right after death when the body is not stiffened. Primary flaccidity is the best time to embalm the body because the muscles are relaxed, and embalming preservatives can easily interact with the proteins in the muscle tissue. After rigor mortis passes, the body enters a state known as secondary flaccidity, where the muscles begin to relax again. This process usually occurs 36 to 72 hours after death, depending on various factors such as temperature and the condition of the body. But once rigor mortis has passed, it does not reoccur. And this is just a really simple chart I created to point out the timeline of rigor mortis and kind of what happens. First, we have the primary flaccidity, which occurs right after death. Then rigor mortis happens usually 2 to 4 hours following death. But of course, intrinsic and extrinsic factors play a part in how quickly or how slowly this happens. And finally, we have secondary flaccidity, which occurs 36 to 72 hours after death. Okay, so embalming a body after rigor mortis has set in leaves the embalmer with many challenges. It is the embalmer's job to know how to correct these problems to create the best outcome. One of the main difficulties is extravascular resistance, which happens due to the muscles and tissues becoming rigid. This rigidity can make it harder for the embalming fluid to flow through the body and properly preserve the tissues. The stiffened muscles can also cause body positioning challenges, making it difficult to position the body in a way that allows for good fluid distribution. There is also an increased demand for embalming preservatives because it is more difficult to penetrate the muscles. This means that a larger volume of preservatives will probably be needed to achieve a good result. A change in pH could change the chemical reactions that typically take place during embalming, leading to less effective preservation. As the embalming fluid is injected into the body, it may cause some tissues to swell due to the resistance from the stiffened muscles. After rigor mortis passes, though, the body can show signs of false preservation, and once rigor passes, this does not always mean that the body has been properly embalmed. Embalmers must be cautious and thorough to ensure that the preservation process was effective. So, rigor mortis plays an important role in the process of embalming, and understanding its chemical basis is crucial for successful embalming practices. By recognizing the signs and timing of rigor mortis, embalmers can better plan their work and avoid the complications that arise when embalming after rigor has set in. Also, understanding the chemistry behind rigor mortis allows embalmers to enhance the effectiveness of preservation techniques to ensure the body is properly cared for. The more embalmers understand about the chemistry of death, the better equipped we can be to perform our duties and create natural, lasting preservation results. Alright, that is it. Thank you so much.